Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're wrapping up 5.1 and we're talking about scientific notation. And we talk about scientific notation in this chapter specifically because scientific notation works with exponents. And scientific notation basically is a way of writing very large or very small numbers. Okay? It uses powers of 10 in order to represent the decimal movement. Remember that when you multiply by powers of 10, guys, you move the decimal to the right for as many zeros as there are. When I'm dividing by powers of 10, I move decimals to the left for as many zeros as there are. Positive exponents are used for original numbers in absolute value that are greater than 1. Okay? So when you have an absolute value of any number that's greater than 1, you're going to use positive exponents. I don't care if the actual number is positive or negative. But if the absolute value of it is larger than 1, then you're going to go ahead and use positive exponents. Negative exponents are used for original numbers in absolute value that are greater than 0 and less than 1. So in other words, decimals. Okay? How do we convert a number in standard form to scientific notation? Super simple. Listen to me, please. What you're first going to do, guys, is make the value of the given number a value between 1 and 10. No, I don't want it to be 10. I want it to be between 1 and 10. Okay? I want to make that value a number between 1 and 10. It can equal 1, but it cannot equal 10 by moving the decimals left or right. If you're moving the decimals to the right, that means you are working with decimal values which are less than 1, so you must use negative exponents. If you are moving decimals to the left, that means you are working with values that are larger than 1, so you must use positive exponents. And I have a little trick for this, because a lot of time the whole left and right thing confuses people like me when I was a kid, so I came up with something to always remind myself whether to use positive or negative exponents, and I'll tell you about it right now. So here, I got 22,300. I need to make this a number between 1 and 10. So I am going to find my decimal, which is always at the right of any number unless specified elsewhere. And I'm going 1, 2, 3, 4 to the left. So this is 2.23 times 10 to the 4th power. Now, this is where the whole left-right thing can potentially confuse you. Whenever I'm going from standard form scientific notation, if I go to the left, I'm using positive exponents. Sometimes we forget this. So this is how I remember. Guys, was this original number larger than 1? I don't care if it's positive or negative, so let me rephrase that. Was this original number, the absolute value of it, was it larger than 1? So when the original number is larger than 1, use positive exponents. That's it. Forget about the stupid left or right thing. You know you're going to have to move left or right, but sometimes you forget, oh, I moved left. Is that positive exponent, negative? Forget about that. Think of the concept. If the original absolute value of the original number is greater than 1, positive exponents. Done. Over here, it's negative 1,250,000. So I'm going to go 1, 2, 3, 4, 5, 6. So this is negative 1.25 times 10 to the positive 6th power. Not because I remembered, oh, I went to the left, so it's positive exponents. I don't think that way. I use a positive exponent because I know that the original number was larger than 1. Now you may say, Morrow, it's a negative. It's the absolute value. I don't care if it's positive or negative. Now, for C, I got 0.0023. So to make this number between a value between 1 and 10, I got to go 1, 2, 3 to the right. By definition, by what most teachers will tell you, by what all books will tell you, if you move an original value, the decimal, to the right, you're using negative exponents. I don't think of it that way. I'm going to go 2.3 times 10 to the negative 3, not because I moved to the right, but because the original number was between 0 and 1. So when the original number is a decimal, I'm using negative exponents, period, always. Forget the silly left or right thing. If the original number is larger than 1, positive exponents. The original number is a decimal value, less than 1, negative exponents. Does that help? Okay. And then here, 0.035, 1, 2 to the right, so it's 3.5 times 10 to the negative 2. Not because I went to the right. Yes, that's the real reason, but I don't think that way. 0.035, oh, that's a number between 0 and 1, so it's got to be a negative exponent. Does that make sense? Converting scientific notation to a number in standard form. This is the easy part. When a number written in scientific notation has a positive exponent attached to the base of 10, simply move the decimal of the number shown to the right as many places as there are exponents. Fill in the gaps with zeros. When numbers written in scientific notation has a negative exponent attached to the base of 10, simply move the decimal of the number shown to the left as many places as there are exponents. Fill in the gaps with zeros. So this is the easy part. I got 8.3 times 10 to the fifth. So there's 8.3. I'm literally going to go 1, 2, 3, 4, 5. Fill in the gaps. Clean it up. 830,000. Why did you go to the right, Moro? Because I had a positive exponent. Now, this is why I don't like the whole left and right thing in the other section, because they're reversed if you notice, guys. If I have an original number that's larger than 1, I go to the left to produce a positive exponent. But when I'm going from scientific notation to standard form, if I have a positive exponent, I go to the right. They're opposites, aren't they? Well, I've noticed in my 20 years of teaching that a lot of people get that mixed up. So stick to what I'm saying. If I'm going from standard form to scientific, the number is larger than 1, positive exponent. It's between 0 and 1, negative exponent. When I'm doing scientific to standard, just follow suit. If it's positive exponent, you go to the right. Negative exponent, you go to the left. So 4.2 times 10 to the negative fourth, I'm going to go 1, 2, 3, 4 to the left. I show my arrow showing me where to put my new decimal. Fill in the gaps. Clean this up. 0.00042. Does that make sense? Sir? No, you can put a 0 for sure. You should technically, yeah. Yeah, I'm a little bit lazy about that. Thank you, my man. So 3.75 times 10 to the negative 6. So I'm going 1, 2, 3, 4, 5, 6. Fill in the gaps. Clean it up. 1, 2, 3, 4, 5 zeros, 3, 7, 5. By the way, who would want to really work with this number right here? Nobody. Neither do scientists, guys. That's why they have scientific notation. It's a lot easier to work with. And then last but not least, 6.5 times 10 to the third. I go 1, 2, 3 to the right. 6,500. Well, let's clean it up. 6,500. Pretty simple, right? You guys have seen scientific notation before, right? Did it make sense today, though? For sure? Thank you, brothers. Now, last but not least, guys. Okay, got to multiply sometimes numbers that are already in scientific notation. Well, there's very simple rules. Number one, multiply or divide the numerical values first. Multiply the numbers first. Then multiply or divide the bases of 10. Remember to use the law of exponents. Hint, hint. And then step 3, write the product or quotient in proper scientific notation. The numerical value, remember, must be or lie between 1 and 10. So you're going to multiply or divide the numbers. You're going to multiply or divide the powers of 10. And then you're going to simplify. Now, I know that some of you are writing, but I'm really running out of time. And I can finish this up right now, so I'm going to move on. I'm sorry, guys, but just watch the video if you didn't get those rules. For example, 3 times 10 to the third times 8 times 10 to the sixth. First, multiply the numbers. 3, whoa, that was weird. 3 times 8 is 24. Times, what's 10 to the third times 10 to the sixth. The bases are the same. Keep the base and add the exponents. Dot, 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 dot. 9. You see that, boys? Now, here's going to be the separation of the A's and the B's and the C's. Is that in proper scientific notation? Now, I got to move one to the left, correct? Now, remember, when the number is larger than 1, am I using positive or negative exponents? So I'm going to add an exponent to the 10. So this becomes 2.4 times 10 to the 10th. Why? Because I moved the decimal one more to the left. So that means I'm adding another exponent to that power of 10. Does that make sense? 15 divided by 0.3, just for giggles here, it's going to be divided by 0.3, it's 50. So I've got 50 times. What's 10 to the negative 6 divided by 10 to the 4th? No. Remember, no. If you make it 10 to the 10th, that means that it's going to come down here. For scientific notation and scientific notation alone, you will be allowed to use negative exponents. So you're going to actually bring this guy up. So it's going to be 10 to the negative 6 times 10 to the negative 4th, which is 10 to the negative 10th. Now, is this in proper scientific notation? No. This number here has to be a value between 1 and 10. So I'm going to go 1 to the left. Was this number larger than 1 or less than 1? Larger than 1. So am I adding or subtracting to the powers? Adding. So this is 5.0 times 10 to the negative 9th. Do me a favor, guys. Do D and C in addition to your regularly posted homework. Thank you so much. God bless you. Hope you learned a lot and have a great day. Be well.